Right, Dr. Clark's PowerPoint. So this mirrors those sheets that I emailed in the original email yesterday. Today, we're on tomorrow, yeah, Tuesday night. So I'm going to run through these super fast again. You can access these, pause them, go back, use your notes, books, revision guides, etc. And your syllabus, of course. Don't forget your syllabus. This is just an overview of the muscle structure and how it contracts, not the chemistry and the biochemistry of how it actually contracts. So we're only going to go superficial at this stage for now. So muscles. Let's have a peruse through what we've got. Yeah, pictures of muscles, great. Muscles, right, responsible for movement. So again, this is mimicking or paralleling what we looked at in the previous PowerPoint. So I'm showing you both because they're very, very different, but kind of give the same information. So this gives you the information to fill those sheets in. In this little series of sheets that you've got, I think there's 2 or 3 pages in that from memory, 3 maybe 4. You can have a go yourselves, but obviously use this to verify, confirm and fill in any gaps that you may have. So cardiac, smooth and skeletal, yep. Talks about what it does with joints, tendons, forces, collagen, strong, stiff, yeah, excellent. Contract or relax, they're the only words you use when you talk about muscles. Pulling forces, yep. Can only pull, they can't push. Antagonistic, we've seen that animation before, so we can leave it. A joint, again, should you ever need it. I'm not sure why you would, but there you go. That talks about it. Bicep, tricep, yep. Muscle structure, single muscle contains approximately 1,000 muscle fibres, yep. These fibres run the whole length of the muscle, indeed they do. Joined together at tendons, remember, yep, tendons join muscles to bone, remember, very little flex if anything. In terms of structure, this is an overview of one of those muscle fibres. You'll notice the idea that it's got lots of nuclei in there, multinucleated cell, lots of cells joined together, share a common cytoplasm called a sarcoplasm. We're only showing part of it, typically 100 micrometers long, which is pretty big, 10th of a mil, centimeters, decent. Yeah, giant, indeed they are giant, very big, huge. Continuing this, they're packed full of myofibrils, these are the contractile units. Bundles of protein filaments that cause it contract, yep. Again, sarcoplasm. Important this bit, lots and lots of mitochondria, lots of RER, and again, thinking about why, ATP, active transport movement, calcium ions, etc. Don't want that because I think we've already seen it as again. Right. There's a bit more detail on the two structures, the actin and the myosin. It refers there to the actin being 2 strands coiled around another with a 3rd strand called tropomyosin. So actin is the white stuff, this is your actin here. Spiraling around this is your tropomyosin. Not mentioned on this, but it will be on the next diagram on the other format. Is a 3rd molecule called troponin. Troponin is not on your syllabus, but you can't teach this without talking about troponin. So I will mention troponin, so it's a useful off-topic protein, which in effect binds to tropomyosin. The thicker molecule of the two within these myofibrils is myosin. Myosin is made up of these, they're almost like little golf clubs in effect, a double-ended golf club. 2 heads on this one club, so a long thin molecule with this club-like head at the end, a bit like it says double-headed golf club, and lots of these are bundled together collectively, and it's these myosin heads which connect to this actin in effect, and this is what joins these two together, but it can only do that when tropomyosin isn't in the way, and surprise surprise, calcium causes this to move and allows this to bind and do its magic. So more of that going forward. Various pictures there looking at thick filaments, thin filaments, cross bridges. I'll click that one, that might help. More about that later on, this idea of thick and thin and cross bridges. A bit more detail, yeah. We've looked at this in the previous animation. We've got a cross section through this thing, and here you can spot the thicker myosin, the thinner actin. Again, you get a feel for it. So here's a micrograph of some actual skeletal muscle, and you'll see here are Z lines, which you mentioned last time. So Z line to Z line is a sarcomere. This region here with the A band, that's in effect the myosin, so that's the length of the myosin. These regions where it's pale and pale, this is the I band, so this is where it's just actin. This is where it's actin and myosin, and then you've got this region in the center which is your H zone where you've got just myosin. So myosin, actin and myosin, just actin. And this central region down here is your M line, and that's basically where the myosin golf clubs this side join the myosin golf clubs going that way. And when we get contraction, basically what happens is that these Z lines get nearer together. The A band stays the same, the I band gets smaller, and yeah, we have muscle contraction. So the I band, why is it called I? Now, isotropic or I band or lighter band. This region here is lighter, as in it appears paler, because it's only got the thin filaments in it. And there's a dark line down the middle called a Z line. So this is where you've got some actin joining on to some other actin. One sarcomere, another sarcomere. This is just like the interface between the two, where the two strands are joined together. So A to Z, actin attaches to Z line, yeah, fine. Muscle structure, so the darker bands, it says they are 3 sections. 2 are darker as they consist of both actin and myosin. So within this, we'll look at this one from down here, for example. This here is actin and myosin. This region here is just myosin. This is actin and myosin. All will become apparent as we go forward, hopefully. This region, the H zone in the center, yeah, so here is, so from there to there, this A band, that is the length of myosin, but this here is the myosin combined with the actin, and as a result you've got double strands in here. You have a strand of actin, a strand of myosin, a strand of actin, a strand of myosin, so on and so on and so on. This is just actin, appears paler. This you've got all the lot in ranged in, so therefore it appears on this micrograph very, very dark. The light can't pass through it. It gives us a darker image. From one Z line to another Z line is a sarcomere. If you learn nothing else tonight or today, tomorrow, remember Z line to Z line is a sarcomere. That's the contractile unit. M and M, myosin attaches to M line. Yeah, that's where the myosin's. So this is a slightly cartoonized version of it. Take a peruse if that makes sense. Here we've got myosin. Here we've got the red actin. It's red on this one. Where you've just got the thin stuff, it appears pale. Where these two are together, they're overlapping, it appears dark. Where you've just got this M on its own, it then appears paler. This long thin line here is your M line, that's where the myosin join the myosin. And it repeats on the opposite side, so this just carries on ad infinitum. H zones, I bands, A bands, you need to be familiar with all this. Don't say the significance of the hands, we'll talk about that after. This is a nice little diagram in that it shows Z line, actin, actin, here's the myosin, this region here, they overlap, so this would appear dark, this would appear lighter, and this would appear the lightest. The plus and the minus ends, ignore them, you don't need any reference to them. And this H zone in the middle is where it's just myosin on its own without the golf club with it. These cutaways come up very often in PPQs. Explain what's happening here. Well, you've got actin and myosin, so this must be in the A band. Yeah, this is just myosin, this must be just H zone. This is just actin, this is part of the I band. And then this nice little diagram joins several together to illustrate what we're going to get going forward with this contractile unit. Yeah, so there we go. And that's a real deal one, which makes, again, some sense once you know what you're looking at. I'm going to leave it there for now. Use that, use what I've done, use the previous one so we can complete Clark's documents. Next little setup tomorrow, we'll go through the actual mechanics of muscle contraction. Hopefully it's making some sense. I know it's not the real deal, unfortunately, but hey ho, we'll make the best of it. Thank you for your time.